This is kind of the summary of the whole of discrete structures. Almost everything that we are going to talk about is here. All right, let me ask you guys, okay? Let me involve you guys. What do you guys think these things are? Okay, let's start with logic. What do you guys think is logic in the context of this discrete structures class?
It could be a bunch of and or if else statements.
Good. So what's your name?
Nofil.
Okay, Nofil says that it could be a bunch of and or not type of statements. That's what you said, right? Okay. Anyone wants to add on that?
There's a thought process behind the solution for problem.
There's a thought process behind the solution of a problem. Okay, good, nice. Okay. To prove
What we have done.
Okay, awesome, good.
A combination of relational operators.
A combination of relational operators. Okay, nice. Okay, good.
Arguments for what we have shown.
Arguments for what we have shown. Okay. Awesome. Really good idea. And almost all of them are correct. To combine all of these, the way humans or us communicate is through a language, right? And the languages that we use for this communication happens to be ambiguous. Okay? At times, language needs supplements. At times, it happens that someone gives you a sentence which is grammatically perfectly correct. But then you ask them, what do you mean? Can you rephrase this? Right? There is at times need for this. Okay? There are words with double meanings. There are sentences with double meanings. Right? That creates a problem for a word where you want to be deterministic about things, where you want to be sure that if I take these 5 steps, I will always get this promised output. Okay, that's the word of computer science, right? Where you want to be deterministic, right? Logic is a foundation or a language that we design to study computer science, which is unambiguous, unequivocal. The sentence that I write down using relational operators, and operator, not operator, or whatever, what I'm trying to convey is an idea that cannot be misinterpreted. Okay? It should always mean the same thing in any word you go. Okay? If there's an alien coming, you just give them a set of logic rules. They would always be able to reach the same conclusion that we reach in this word. Okay? So that's what logic is. That's what's fundamental about logic. That it's a language that is absolutely unequivocal and unambiguous. Okay? Okay. Proofs. What are proofs? So proofs are in the language of logic. In the language of logic, proofs are a series of
Justifications.
deductions and based on justifications. Okay, where each step is easily justifiable. Okay, so where going from start to end, you start with some statement and you end with some statement. This step-by-step process is proof if each step is logically true and easily deducible. Okay? 2 चीजें हैं उसका पार्ट. एक तो it must be true कि वो गलत नहीं होना चाहिए किसी स्टेप के ऊपर ना. And second part is each step should be easily deducible. उसको किसी को कन्विंस करने की जरूरत ना पड़े कि इस स्टेप से दूसरे स्टेप से तीसरे स्टेप पे आप कैसे गए. Okay? So that's proof. Sets? That should be easily definable. What is a set?
Well-defined set.
Collection of
Distinct objects. Well-defined set of distinct objects.
Well-defined,
Distinct objects. Unique.
well-defined, distinct objects.
collection of distinct objects.
Collection of
Distinct objects.
collection of distinct objects. I'm still missing one keyword here.
Well-defined is well-defined collection of distinct.
No, well-defined is not the word I'm looking for. Unrepeated. So distinct is there, right? Distinct means that you cannot repeat them. But good.
With similar qualities.
No, not at all. That was a lie. That was told to you in high school. Okay, oh, we don't care about how similar they are. Okay,
Comparing different things.
there's one nice thing that you kind of all have that in your mind, but you are not able to express it because you kind of assume that ये तो होगा, ये तो definitely. I mean, I'll tell you and you'll say, हाँ ये तो I know this is what it means, right? What is that word? Order. Sets में order नहीं होगा. Okay? Unordered collection of distinct things. Okay? That's the set. Order, what that means is, why do I need to say this? Okay? The reason I need to say this is, when I write 1, 2, 3, and then I write 3, 1, 2, what I mean is the same object. अगर ये दोनों चीज़ें sets है ना, I mean the same object. Okay? अगर मैं ordered नहीं, unordered नहीं कहूँगा, तो फिर these two things could be different. Okay? And when I order them, I get a different object. Okay? Okay, nice. So that's what sets is. We'll talk about sets. Functions, can anyone define it? I'm not going to define function, by the way, but I just want to hear what people have to say. What function is?
It is a program which takes inputs and gives certain outputs.
Good point. Okay. It's a program which takes some inputs and throws out some outputs. Okay?
For each input, we have only one output.
That's actually more of what I was going for. For each input, you have only one. Okay? So you cannot get two different outputs for the same input. Okay, good. Binary relations. Okay, let's skip that. Okay, because that requires some context. Computation. Anyone about computations? Compute. What?
Processing.
Okay, so this is about how to define it at this point. The amount of computational resources required to do something. Properties of integers, counting. That's kind of the last two things are my kind of. Actually, everything is my favorite, but counting in graphs. We'll spend last few weeks on those. Everything before counting is kind of a ingredient. Okay, it's kind of things that we need, or counting and graphs are kind of a recipe. Okay. Just keep this thing in mind. When we come to counting, I'll repeat this sentence and I'll ask you, are you convinced that this is what it was? Okay? Everything up till counting is kind of an ingredient. And then we come to counting, we'll talk about recipes. Okay? We'll talk about creating new things. Okay? Questions? All right. Let's start with an application. So, let's say you work at a company that wants to market a new cell phone. Okay? So no one knows about their cell phone. They create this new amazing cell phone. What they want to do is they want to give away fewest number of those cell phones to people around, so that almost everyone knows about their product. Okay? That's a typical marketing strategy, that you create a product and now you want to spend some money to convince a very few set of people. जिनको हम influencers कहते हैं. We give them away a few things to even review, and then since they are influencers, so they have a larger circle of people who are connected to them. So if they know about your product, a lot of people are going to know about your problem. Okay? So that's a typical problem. It turns out it's a discrete math problem. Okay? If it's a discrete math problem, then we should be able to see some of these objects there. Okay? Let's see how we find those. So there is this relationship among people, which is that I know him, or he is my friend, or he's my neighbor, or he's influenced by this person. Okay? That's a relation. We need to model that relation. And that relationship is modeled by something called a graph. Okay? So what happens in graph is that we represent entities, or in this case, इस example में जो individuals and humans हैं, part of society, या जिस community को आप target कर रहे हैं. For example, you only want to target people in Lahore. Okay? So everyone in Lahore would be kind of a circle in this graph. Okay? इस चीज़ को मैं graph कह रहा हूँ. This is different from the graphical thing that you make. Sorry? So हाँ कार्टेशियन कोऑर्डिनेट्स के अंदर जो चीज़ बनाते हैं. It's irrelevant कि मैंने इसको कहाँ पे बनाया है. Okay, इसकी लोकेशन से कोई फर्क नहीं पड़ता. It's a discrete object. Okay. Okay, so that's that. And then I connect two dots if they are friends with each other. Okay, if one has a phone, the other definitely knows that this guy has this new phone. Okay, so that's how I can kind of map this relation. And this thing is the graph का structure इसको हम कहते हैं. Does everyone know what a graph is by now? Okay, so it's a bunch of entities and the relationship between pairs of those. Okay, so some pairs have that relation, some pairs do not. So for example, अगर मैं इनको label कर दूँ 1, 2, 3, 4, तो फिर 1 and 2 have a relation, but 1 and 3 do not have a relation. Okay, so what that would mean is कि 1 and 2 are friends, 2 and 3 are also friends, but 1 and 3 are not friends. Are we good? Okay, so that's where we use graph theory to model such relations. So how many free cells are needed to cover the whole graph? 3, 4, 5? So if I have, for example, these 5, someone said 4. Who said 4? Okay. So if I give phones to these 5 people, then you'll see that everyone is covered, right? Everyone either has a cell phone or their friend has a cell phone. Everyone is connected to someone who has a phone, right? All right? Which means that 5 cell phones are enough. If I give away 5 cell phones, then the whole graph would be covered, and my marketing strategy would be kind of successful. He says, what's your name? Ali. Ali says that we can do it with 4. How can we do it with 4?
Sir, in the modeling friendship.
What did you just call me?
Professor, in the modeling friendship, it said that we should represent the phone with the corner edges and not in the center.
Okay, that's okay. Repeat it again one more time.
The modeling friendship before this slide
Yeah.
said that we should represent friendship as edges and not in the center.
So okay, so modeling a friendship is just this line segment. Okay, this line segment tells you that these two people are connected, right? At this point, we are just deciding. Okay, so question is, are there 4 people here who could be the good influencers? If I give them phones, then everyone will know about the phone that I'm giving away. So are there 4 people here who could be my influencers? Bolo? Center me? Bolo? So let me label these, okay? Let's say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14, okay?
Center 4.
So this is 13 and 14. Give me the number of the nodes. If I give them cell phones, I would have everyone.
Center 1 and 4.
So you're saying that if I give them to, what was this number? I forgot about it. 6, 7, 11, 12. Then everyone would be covered. Is that true? I think you're right. Which one? ये रह जाएगा है ना? ये रह जाएगा. Good catch. Anyone else? Okay. क्या?
अगर हम 4 सेल फोन यूज करें तो कवरेज हो सकती है सर.
Okay, बोलो कौन से हो?
अगर हम 2 पे रखें,
एक 2 पे रख रहे हो? Okay.
एक 8 पे रखें,
यहाँ पे. Okay.
एक हम 9 पे रखें
यहाँ पे. Okay.
और एक 14.
14. Okay. 2, 8, 9, 14. Let's check. 2 covers this thing, right? 2 covers these 3 things. Oh, how would you cover this thing? 3. Oh, 2 से cover हो जाएगा. Okay, so 2 से you will be covered 1, 2 and 3 and 6. Okay. If you have this, you would be covering this guy, sorry, and this. And then you have this covers these 2. And then you have 14, right? Yeah, I guess that works. Good. Okay, nice. So 4 works. Fine. 5 phones are sufficient. But necessary question was, do we need 5? Okay. The answer is no. We don't need 5. 4 से काम चल जाएगा. Okay. And here is another solution. एक आपने दिया, which helps you find 4 phones for this. The question is, can we do better? And that's one part of what discrete math is, that you actually prove that there is no way to improve on that. Okay. For this question, the answer is no. We'll see how that works. Actually, I have a slightly more interesting problem. Can you guys read the numbers in there? Let me read for you. Okay, so this is 0, this is 8, this is 7, this is 2, this is 5, 3, 6, this is 4, and this is 1. Okay, let's have a look. How many do you need for this one? You need 2. Which ones?
3 or 7.
3 and 7. Let's check it. Someone says 3 and 7. Let's check 3 and 7. Okay, you said 3 and 7, right? Let's see. You want to take 2 and 7? So 7 covers 8, 4, and 1. That's right? And 0. And 3 covers 2, 5, and 6. So it works. 3 and 7 works, right? Okay, let's do it with 10. Okay, how about this one? This is the last one, I promise.
7 and 14.
7 and what?
1.
7 and 1?
1, 7.
Yeah, I made them very dense. 7 and 1. Let's try. I think you're right. 7 and 1 is the answer. Anyhow, okay. So the point I want to make here is that this is a very small, tiny graph. Okay, this is 8 nodes, 7 nodes. Do you guys know how many nodes are in the Facebook graph? There are a few billion nodes there. Okay, there are 5 billion nodes in there. Okay, think of the scale of problem this would be on a Facebook graph. Okay, even you pick a small community on a Facebook graph, people from Lahore, it would already be in millions. Okay, and this problem would be super hard to solve even on those problems. Okay, so compute becomes really important there, that you want to make sure that your solution is efficient. It does not take so much computational resources. Okay, so I would want you guys to keep the big picture in mind, और इसकी reason मैं अभी आपको 1 minute में बताता हूँ, and then be able to connect things, because see, okay, मैं बहुत पीछे जा रहा हूँ. There are a lot of moving components and they are not directly connected to each other. Okay, so you would want to be able to translate knowledge from one part of the course to another. Okay, that's what I mean by connect. And also you need to be part of dialogue. Okay, no matter how many times I repeat this always is the deficiency I always find in students, that they don't talk to me too much, okay, or the TS too much. Okay, so let me say it this way. Okay, you're not gonna be wrong overdoing it. Okay, there is no bar जहाँ पे आप कहेंगे I'm overdoing the dialogue thing. Okay, okay. Just for a summary, this course is mile wide and foot deep. What does this mean? What do you guys this mean? This is mile wide and foot deep. Yeah.
It will cover a lot of topics, but nobody must learn.
Absolutely. Yeah. So we are going to cover almost every other week. We're going to start a new topic, a new thing, a new, I don't know, even subtopic, and we'll move on from that topic. 2 weeks गुजरेंगे तो you'll see that you're at absolutely fresh start again. Okay, and you will lose the context of the big picture. Okay, that's why it's really important to keep the big picture in mind. Okay, I'll try to keep reminding you कि हमने last क्या पढ़ा था और अब हम क्या पढ़ रहे हैं, but you need to keep that in mind. Okay, participate again. I'm kind of broken pipe की तरह मैं आपको बार-बार कह रहा हूँ. You need to participate more and more. Okay. This is a complaint I hear a lot, that I'm kind of going to make sure that you understand everything in class. That's not going to be a problem. That's usually not the problem that you're in the class, you're coming to the class, there is something that you don't understand in the class. The problem is usually that when you go back home and you look at the homework or the quiz, you are totally blank. You have no idea how to solve those problems. Okay? And the way it works is that you get to practice a lot. Okay? You'll see a lot of practice problem on the slides in class, and these guys, Mehreen is here, Barira, they're going to be available on Slack. They'll point to problems in book which are related to the problems in book in the slides, and your job is going to pick that up and do the problems from the book जो हमने क्लास में डिस्कस नहीं किए होंगे. Okay? वो अगर आप नहीं करेंगे तो you will lag behind. फिर आपसे क्विज नहीं होगा, फिर आपसे एग्जाम नहीं होगा. You will fail this course. Okay? All right, let's start with another example based on logic. Let's read this. So we have two statements. One of them is a thief. So we have three people, A, B, and C. A says, I am not the thief. B says, A is the thief. And C says, I am not the thief. Okay? We know two statements to be true. One of them is definitely thief. Exactly one of them is speaking the truth. Okay? Based on this, we want to conclude or find out who the thief is. Okay? Let's see how we do it. Pay attention to the process and not the answer. Okay? You might jump to the answer. Okay, I know this guy is the thief. The more important part is the process. The process, we're trying here to formalize or systemize the process that we use to reach the conclusion. Okay? So we start by supposing things. We suppose that A is thief. If this is the case, then both B and C are speaking truth, right? C is saying that I'm not the thief. If A is thief and there is only one thief, then C is definitely speaking the truth, right? And B is saying that A is thief, which means that B is also speaking the truth. But that's not possible, right? Because we know that exactly one of them is speaking the truth, right? So that's a process that we used to eliminate the statement that A is thief. All right, so we use this process of elimination to eliminate one of the supposed conclusions, okay? If we reach there, the second thing is we assume that B is the thief. Can you argue about why B is or is not the thief before looking at the next slide?
B is not the thief because A is also saying that he is not the thief, and C is also saying that he is not the thief. So two corrections.
Okay. So if B is the thief, there are two statements which seems true. Okay, where A says that I am not thief and C says I am not thief. Okay, which means that you want to add something.
C is the thief.
Yeah. So again, the thing is, we on this slide we proved that the statement that B is thief is wrong. Okay, because it contradicts one of the assumptions that we started with. Once we know that A and B are not thieves, then the statement that exactly one of them is thief gives us the answer, which is that C must be the thief. Okay, and we can verify the statement as well that this agrees with our original hypothesis. All right. Okay. So again, pay attention to the process that we are using to reach a conclusion. This problem could become extremely complex pretty easily, okay? Assuming that you have, for example, n people and exactly k of them are speaking the truth, and you have a few bunch of other constraints as well. That's why it's important to kind of formalize the system or systemize the process instead of just concluding a solution, okay? Let's look at another example. Our focus again is on the process of reasoning. We have three statements. One is it's snowing in New York. I should write New York City, but in any case, if it snows in a city, then its schools are closed. This is the second statement. And the third statement is that if it snows in New York, then it snows in Boston. Okay. what do we want to do? We want to conclude from these three statements that schools in Boston are closed. Can we do this? It seems that we can. Here's the process. These are the statements that we have, and we made boxes for those statements. And then the relationships could be arrows. Okay. From the first statement, I can deduce the second. Okay. Since it's snowing in New York, and I have that if it snows in New York, then it snows in Boston, this arrow is valid. Okay. It tells me that it's snowing in Boston. ये वाला arrow मुझे कैसे मिला?
Second statement.
Yeah, from this statement. Yeah, second statement, which says that if it snows in a city, then schools are closed. Which means that if I plug in city with Boston, I would get this statement, which says the schools are closed in Boston. Okay. I also get a separate statement, जो required नहीं थी मेरे लिए, which says that schools are closed in New York. Okay. Are you following me? Are we on the same page? Okay. So to formalize, we have a bunch of statements, okay, and then we have kind of something about these statements, which is that either these statements are true or false, yes or no, okay. That's going to be our groundbreaking. That's going to be our ground on which we are going to build our building. Okay. What do you guys think? How would you define the statement? What's the statement mathematically? If this is our ground needs to be solid, right? We should unequivocally, unarguably know what each of those breaks are, right? So statement seems to be one of those breaks. So what is the statement?
Proposition that
You're using the words which are breaks that we don't know about yet. Okay? Let's use things which are unequivocal, unarguably we know about them before we embark on this journey of defining things for logic, right? So how would you define a statement?
Something which is permanent or unambiguous. I mean, it doesn't change in the course of others.
Okay. Okay. Yes.
repetitions of steps.
Yeah. So the way I would define it is that it has a truth value. Okay. It's either true or false or both. Okay. So there could be statements which are simultaneously either true or false. Okay. So a statement is जिसके बारे में हम ये कह सकें कि ये या तो yes है या कोई कह सके. Okay. Again मैं इसको थोड़ा और broad कर रहा हूँ ना. Statement is anything जिसके बारे में या तो कहा जा सके कि this is a fact या कहा जा सके कि it's not a fact या कहा जा सके कि maybe it's a fact or maybe it's not a fact. Okay. इससे ज़्यादा we cannot be more general, right? This is as general as we can get. Do we agree on this definition of statement? Okay, let's move on then. What could be a good way to capture relations between statements? I talked about it a moment ago that what we are going to do in proofs is that we will have statements and we are going to have relationship between statements, which would be if I have this statement, then I definitely have this statement. Okay, that could be one possible relation. Another possible relation could be that if this statement is true, then this statement is definitely false. This could be another relation, right? So you can define connections between statements in this way. इसको हम थोड़ा सा और formalize करेंगे. But these two connections should be obvious. If I have a statement, if it's true, this other statement is also true. This is a very simple relation. Okay. Another relation is that if this statement is false, this other statement is definitely true. Okay? How can we write new statements from new ones? That's also we're going to learn कि हम ये कैसे करेंगे. For that we were going to need operations. जो थोड़ी देर पहले लोग कह रहे थे कि हम आपने शायद कहा था कि we can use and, we can use or, and we can use not operator. All right. this kind of formalization gives us a way to create precise mathematical arguments, proving them by these connections, and verifying correctness of computer programs, designing computer circuits, writing algorithms. Okay, and to pass this course as well, right?